12C. Now 12C is not new. If you guys remember this absolute maximum minimum, you did that in unit 3. You vaguely remember?
Yeah.
Yeah, Suleiman, what do you remember?
I'm pretty sure it's like, let's say if it's an absolute maximum, it's like the highest point.
Very good.
And the minimum is the lowest.
Yep, highest and lowest point, correct. Highest and lowest point. So how do we find these? Like, what are the steps? There are only 2 steps. I think last time I explained it, there are only 2 steps. Alright, because so they always start with, so first is find the y value for something. Right? They both start with find y value for something. But what are we finding the y values for? There are 2 things that you need to find the values for, and then you get your absolute max and minimum. You guys remember? So the first thing you need to find is find the values for all turning points or stationary points. Okay, sometimes it's not exactly turning points, so call it stationary points, and I'll use the short form SP from now. Okay, you can't use that. You have to write stationary point in the exam. Pretty sure. And then the second one, you probably don't remember. Find y values for the start and end point. Start and end points. Now, what do we mean by start and end points? So let's say if I have a function that looks, so that 2 functions. Oh, actually, let's see. So if I draw one like that, and then one like this. Okay, let's say if I have that function there, right? I'll create a window. So a domain, so let's say if you set a domain, right, of between 2 values, A and B, would create like a window like that. Okay, so if I have a domain between this one and that one, what's the absolute maximum? So looking at this one will be the start point, right? This one will be the end point, and this one is the local max, and this one is the local min. Right? If this is the window, which point is the absolute maximum? The end point, right? That's the absolute maximum. Which one is the absolute minimum?
Local minimum.
The local minimum. Yeah, does it make sense? And then if I were to shift the window over to, let's say, if I make the window like bigger here, okay? Now this one would be the start, this one would be the end, and then this one is the local min, local max. So what's the absolute? That one's the min, that one's the local, so local max and local min, right? So which one would be the absolute maximum? The start point. Which one is the absolute minimum? The end point, right? You see what I mean by you just need to find the y values of 2 types of points: start and end points, or the stationary points. So I'll give you another example where the absolute maximum. So let's say if a function looks something like that, right? So it ends here, it starts here. So the absolute minimum is the end point, the absolute maximum is the local maximum. And see, it's just one of these points, right? So the absolute maximum is normally either the start, the end, or the local maximum. And the absolute minimum could be either the local minimum or the start or the end, depend, right? If it starts lower and then goes up like that, then the absolute minimum is at the start, right? But if the top there, it turns around like that, and it ends here, then the local maximum is the absolute maximum. Okay, so I'll show you guys an example of how applying that concept to do the questions. So note that this chapter is like is only a precursor to the next chapter, because normally in the exam you get this question in the form of find the maximum volume. Okay, like find the maximum volume using this formula here, or like find the maximum area of a certain thing. Okay, so that's what you need to find. So this is only like a very basic example: absolute maximum, absolute minimum. All right, so there are 2 things. Remember, 2 things you need to do. So first we want to find the y values for the stationary points, and then the start and end. Right. So the stuff in gray is not what you guys need to write. I'm just writing it so you can differentiate between what I'm doing here. So for stationary point, to find stationary points, you need to derive that first. 2x plus 2, set that equals to 0. Okay? Yeah, for stationary points. Then minus 2 equals 2x, so negative 1 equals 2x.
Isn't it just 2x, the derivative?
2, oh yeah, sorry, you're right. Yeah, 2x, yeah. Yeah, I've been teaching too many lessons today, making too many mistakes. Okay, 0 equals to 2x, so yes, you're correct. It's x equals to 0. Yeah, so that's the first derivative, and then we need to find, remember, we're finding the y values only. So you find f of 0, right, which is 0 squared plus 2, which is 2. So now this is the, we don't even care whether this is local max or local min, because I'll show you what like the visualization is later. So and then we'll find the start and end point. So f of negative 2 and f of 4, right, start and end point. So negative 2 would be negative 2 everything squared plus 2, which is 4 plus 2, that's 6. F of 4 would be 4 squared plus 2, which is 16 plus 2, that's 18. Okay, so looking at this, if I were to plot these points onto like a number line, right? See if I can squeeze this one over here. Oh yeah, I can. Okay, so if I were to plot these on the number line, like that's the y-axis there will be a point with coordinate 2, there will be a point with a coordinate 6, and there will be a point with coordinate 18. So of course, this one will be the maximum and absolute maximum. This is the absolute minimum. Okay, so based on this, you can just conclude straight away. Therefore, absolute max equals 18 and absolute minimum equals 2. Okay, yeah, so that's one example. I'll show you another one. Again, the steps are actually quite standard for most of these questions. So let's see, stationary points. Yeah, this is another one. Once you've got like the y values for these two types of points, it's you literally just look at the max and look at the minimum of these y values. So once again, stationary points, I derived that first. That would be 3x squared. Okay, set that equals to 0. So x would just be 0. So then we find f of 0, which is 0 cubed plus 2. That would be 2. All right, so that's one of the points. And then we find f at the starting point minus 2, which is negative 2 cubed, that's negative 8 plus 2 is negative 6. And then f at 1 would be 1 cubed plus 2, then that would be 3. Highlight all the points here. Okay, so then therefore, literally just look at the maximum, absolute maximum equals 3, and then absolute minimum equals negative 6. Okay, as easy as that, right? Okay, so give me a second, let's pick up. Okay, next one. Now this one seems more like it. Okay, this one is more like a type of a maximum and minimum that you actually see in the exam. So you need to realize like what's the start point, end point, and stuff like that. Okay. From a square piece of metal of side length 2, 4 squares are removed as shown. So what they're saying is that this one here would be 2, right? And then they remove the 4 tiny squares here, right? And to get to this one, and they fold it. The metal is then folded along the dashed line to form an open box. So this one would fold up to join that point there. Yeah, can you guys see that? Just fold up into the box. Okay, show that the volume is given by, again, when you see show that, what do? That's my tip. When you see show that in an exam, what do?
Draw the graph.
Sorry?
I don't know, like
Draw, not drawing, something else. Something else. Remember, when you see show that, what do? It is a very important exam technique to save time and to steal as many marks as you can. You skip it. Okay? When you see show that, you skip. Why? Why do we skip this one? Because you already have the answer. Which means you can move on to the next question without having to go through question A. And another reason why I want you to skip show that at the beginning is it's normally difficult. Okay, so I'll do exactly just that, and I'll skip question A first, I'll go to question B. And I'll show you guys how to do question A later. Question B, find the value of x that gives the box its maximum volume. Okay, maximum volume. So So this, when you see maximum or highest or anything that relates to that, you're thinking about absolute maximum and absolute minimum. Okay, so maximum volume, right? At the so maximum volume, again, remember we were talking about this earlier. You need to find the turning point or the end point, start and end point. So maximum volume, so it's the same as absolute maximum, absolute minimum. So I actually need to derive that first. So v dash or v prime would be 12x squared minus 16x plus 4, right? So remember, you see, we need the start slash end points and the stationary points. Okay, so to do stationary points, derive that first, set that equals to 0, and then solve for x. Okay, divide both sides by 4, I will get 3x squared minus 4x plus 1. ACB table, so AC is 3, B negative 4, so that will be negative 3, negative 1. Non-monic quadratics, hence I need to split the middle term. I'll split it into negative 3x and then minus x plus 1. Take out common factor, 3x, it will be x minus 1. I want x minus 1, but this is negative x plus 1, so I gotta change the sign, take out minus 1. Okay? And then 0 equals to 3x minus 1 times x minus 1. Solve no factor law. Would be 3x minus 1 equals to 0, or you just go x equals to 1 straight away. And then x on this side, move the negative 1 over, divide by 3, would be 1 over 3, or x equals to 1. Okay? Now, how do we know which of these will give the maximum volume? Because remember, these are only the turning point, right? Or stationary points. Okay, these are the x-coordinate of the stationary point, but is it gonna be like that and then that, or is it like this and then that? We don't know. In order to know, we actually need to substitute that into the original value. Okay, let's see. Find the value of x maximum volume. Oh, you need to show that the volume is the maximum for this value. Okay, if you need to show that, then we're talking about show, right? Show that it is maximum means you're talking about proving nature of the stationary point. So how do we show nature of stationary points? Second derivative. Right? Use the second derivative. Remember we went through this last week? Yeah? To prove the nature. So you derive it twice. V double dash would be, use that one there. So that would be 24x minus 16. Okay? Alright? Now, we'll test it at the 2 points. So when x equals 1/3 and when x equals to 1. So v dash double dash at 1/3 would be 24 over 3 minus 16. So that will be 8 minus 16 is negative 8. When x equals to 1, it will be v double dash at 1 would be 24 minus 16, which is positive 8. Now, what does that mean? What does that mean when it's negative? What kind of stationary point is this?
It's maximum.
Maximum, good. Now, I'll go through the steps. So this one means concave down. Right, concave down, so it must look somewhat like that as a stationary point, therefore local maximum. Alright, local max at x equals 1/3. So note how I'm writing all of these answers. Yeah, the gray stuff you don't need to write. Actually, this one should be technically gray, so I'll just change that over. So that one you don't need to write, but anything red and blue you should write. You should write anything red, definitely write them. So make sure your answer is complete. So this one would be concave, therefore concave up, which looks something like that. Therefore local minimum at x equals to 1. Okay, so when x is 1/3, it's going to be the maximum volume. So then find v of 1/3, and that would be the maximum volume. Okay, so that would be substitute 1/3 into the original equation, which is that one there. All right, I'll show you guys something. 4 times 1/3 power 3. Let me see. Did I have? Oh yeah, no, that's right. Okay. 4 times I don't have that example in here. Okay, that's fine. 4 times 1/3 power 3 minus 8 times 1/3 squared, and then was it plus 4 times 1/3, right? Now, if you were to just work through these numbers straight away, it's going to be a pain, I tell you. Okay, it's not easy to work on these numbers straight off, because you need to deal with fractions and you're multiplying a lot of numbers. So, for example, I'll show you. This one will be 8 times 1/9, right? And then this one will be 4/3. Now, but this one though is 4/27. So you got to convert this one into times 27. So times that by 3, times that 1 by 3, and this is a subtraction. So times that by 9, times that by 9. So you're working with a lot of 2 digit numbers. I don't like that. Okay, I don't like to work with 2-digit numbers. What you can do is you take out, take out common factors. See, this technique is very, very common. Used a lot in methods. You take out 4, and then how many of 1/3? One of those. Okay. Then what's left in the bracket from the first one is just 1/3 to the power 2, and from the second one would be I took out 4, so there'll be 2 left, and then took out 1/3, so there's only 1/3 left, and then I took out the entire term from the last one, which should be plus 1. Okay. Now then, this one is a bit easier to work with. 4 times 1/3 is 4/3. And this one is 1/9 minus 2/3, which is 6/9. 6/9 plus 9/9. Single digits. Alright, single digit numbers are a lot easier to work with. 1 plus 9, 10 minus 6, 4/9. 4/9 times by 4/3, right, is 16/27. That's the maximum volume, right? I think in centimeters cube. Meters cube. Okay, so that's the volume. That's the maximum volume, and we already showed that it was the maximum value for that one day. Sketch the graph of v against x for a suitable domain. Okay, so sketch it for a suitable domain. So v against x. Now note that v is a cubic equation. Okay, cubic equation, which means there will be 2 turning points, like that or like that, for cubic equations. Now which one? We don't know. So we're gonna find out. So we actually found 2 turning points. One of them is 1/3. The other one is 1. So let's find out the volume, right, at 1. Okay. So based on this, what we can say so far is that at x equals to 1/3, and then the volume is 16/27, is a local maximum. Okay. And then let's find the volume at 1. So that would be 4 times 1 cube, which is 4, minus 8 times 1 plus 4, which is 0. Okay, so the volume is 0 when x equals to 1. All right, let's see how we sketch this. And then we know that this is the local minimum. Therefore, 1, 0 is the local minimum. Okay, so 1/3 and 1. All right. And then the volume would be, when we substitute x equals to 0, that equation would just be 0. Right? It will be 0 minus 0 plus 0, which is 0. So when x equals to 0, there's no volume, which makes sense, right? It's a flat surface, there's no volume. Right, so let's have a look. Where volume, the maximum is 16/27, which is here. Let's say that's here. And it starts off at 0, 0. Okay, and then when x equals to 1, the volume is 0 again. Right, so this is 1, 0, this is 0, 0. And then it peaks at 16/27 when x equals to 1/3, which is like about here. Okay, so that will be the local maximum. So you can somewhat guess that the shape will look like that, but then again, remember, this is local minimum here. Right, so it actually has to come up like that, and this is the local maximum. Does that make sense? Yeah, because we found out those are the 2 stationary points, right? 1, 0 and 1/3, 16/27. These 2 are the 2 turning points, so it has to be turning point. So yeah, so it will be from here, and then it will join like here. So there will be if you notice, there will be a point of inflection somewhere around here. Do you see it? This is concave down, right? This is concave up. Changing concavity, point of inflection. Okay. If you were to solve the second derivative equals to 0, you can find exactly where that is. So this is the second derivative, right? 24x minus 16. So let's find that. So find point of inflection. Second derivative is equals to 0. So 24x minus 16 equals to 0. So x equals 16 over 24 divided by 8. That's 2 over 3. It's just 2/3, right? It's halfway between here and here. So the point of inflection will be where x equals to 2/3, somewhere around here. So it will curve down to around here, and then it starts curving up, right? Concaving up around that point. And then if you substitute 2 over 3 into the volume, calculate, you can get the y value, but I'll skip that for now. Okay, that makes sense? So that's how you sketch it. It's very similar to last week's chapter. It's about sketching using the second derivative. Now, the height must be less than 0.3. Okay? So x is less than 0.3. What would be the maximum volume? What do you think? Looking at this graph here. If the height is maximum 0.3, how do we get the maximum volume? How do we get a maximum volume? Is it going to be the same? Is it still 16 over 27? If not, then what is it? Yeah. If not, then what is it? 1/3 is 0.33 recurring. So let's just say the 3 decimal places is 0.333. Now, if it's restricted, that it must be less than 0.3. Then what's the maximum volume? This means that the restriction actually cuts it off earlier. Yeah, so for part D, it's actually cut off around here. Yeah, so it hasn't reached the local maximum yet. Does it make sense? Because 0.3 is less than 0.33, right? And because of that, it hasn't reached a maximum yet. It gets cut off at a point before the maximum, which means that the maximum volume is actually V at that maximum, at that end point. Because now the end point is before the local maximum, okay? It's like one of those situations where if you have a local maximum, but the window that you've got is only here. It hasn't, or maybe even like here. It hasn't reached a maximum yet. So then the end point turns into the local maximum. Sorry, the absolute maximum. Does that make sense? Now, if the window, sometimes they give you a tricky question. The window they might give after the maximum point. Then suddenly, this point is no longer the absolute max. The local max is the absolute max. Okay, so it depends on where the window is. So that's why they ask you to sketch it, because most of the time you can sketch it, you can see where the window lies, right? And that's why it's very important sketching skills. So yeah, so now we need to calculate V of 0.3. Same thing, gotta substitute 0.3. So instead of using that, I will write V of 3 over 10. Okay, and I think that would be 4 times 3 over 10 minus 8 plus 4. Okay, so 4 times 3 over 10 minus 8 times 3 over 10 squared plus 4 times 3 over 10. Oh, this is cube. Right? Yep. Same thing, if you have to do this on a tech-free question, and there are some questions in chapter 19 that we'll do for revision later, where they really test your like grade 6 and 7 decimal number and fraction skills. This is one of those. Take out common factor, 4 times 3 on 10. All right, what's in the bracket? That would be 3 on 10 squared minus, take out 3 on 10, so that'll be 2 times 3 on 10 and then plus 1. Okay? Alright. 12 on 10, well, before I multiply, I can actually simplify that first. So that'll be 2 and 5, so 2 times 3 is 6 on 5. Any question there? You get a 6 on 5 here? All good? And then that would be 9 on 100 minus 6 on 10, which is 60 on 100 plus 100 over 100. Okay, this one you can't really do much with it. You have to work with big numbers. But it is still better than working with 1000. So 100 minus 60 is 40, and then plus 9 is 49. So that's 6 times 49 over 5 times 100, which is 500. Okay. If you see it, you can simplify 6 and 500. So that would just be divided by 2 would be 3, and this is 250. Okay. So that's 3 times 49. You can work that out on the side here. That's 81. Oh yeah, I'm just going to do this method here. 81 and then 120, which is 201. Okay, so that's 201 over 250. Yeah, so that would be the maximum volume in cubic meters. Alright, if we were to times that by 4, divided it, I think the volume would be 0.804. Yeah, so roughly approximately 0.804. Actually it's exact, sorry, it's exactly 0.804 cubic meter. Okay, let's see. So 0.3 and is, wait, is 0.588. Whoops, I missed something here. 160, 100 over 100. 3 squared is 9, and then 236 over 5. 40, 49, 120. Oh, it's 27. Been doing too many math, losing my mind here. Right, that's 147 over 350. Sorry, over 250. So convert that back to decimal, times it by 4. 82, 16, 18, 1, 588. Yeah, so 0.588 cubic meter. That's better. Okay, now we are back to question A. So remember I told you guys I skipped question A because it's a show that question. Now that we've figured everything else out, we can try to do question A. Okay, now that we touch the show that the volume is equals to this. Like given this question here, if you see that question, what are you going to do? How do you even start? How do you even start with this question if you see this? You see, this is the reason why when you see show that, you skip it. You just use the result, do the other stuff, because the other parts are normally easier. Like you know where to start, right? Like, oh yeah, maximum derive, set equals to 0, solve x, yada yada. You can get the marks for that, but if you don't know where to start for A, there's literally no way you can start for A. Now, to start for A, you need to understand that you need to use the other information. So what have we not used yet? Side length 2. 4 squares are removed. And then folded to form an open box, height is x. Okay, so what they're saying is that you're going to note in, so this is x here, and then the whole thing would be 2. Okay, so how do we get volume from this information? Can we find the base of the box?
2 minus 2x.
Yes, very good. This is 2 minus 2x. Right? Yeah? So then for question A, volume would be equals to 2 minus 2x, and then you got to times it by itself, right? Because it's a square base, right? Times 2 minus 2x, and then you times it by x again, which is the height. Yeah? So then equals to, expand the first bracket. I'll keep the x in here outside first. Expand the brackets, rainbow method. That will be 4 minus 4x minus 4x plus 4x squared. Okay? And then simplify, moving the x squared at the front, 4x squared minus 8x plus 4. Right? Multiply that back in, the x in will be 4x cubed minus 8x squared plus 4x, which is equals to the right hand side, and this is, therefore, it is shown. Right? So if you know what to do, 4 lines for 1 mark. If you don't know what to do, you can sit there for like 10 minutes staring at it and you still don't know where to start. Okay? So that's why I show that questions, skip it at first. If you have time, come back to it. If you don't, it's fine. It's like a couple marks, 1 or 2. Okay, you can get more marks for the other parts. Don't let the show that question stop you from doing everything else. Okay, so yeah, that's it. Okay, and I think for these exercises, right, we'll try a few of them. Okay, but we'll do it in a format that I'll just start a question, you guys work on it, and then I'll go through the end if there's anyone with any question. Okay, so we'll start easy first. Start with question 1. I'll give you some time to start out first, so you don't get spoiled by my answer. Oh, actually, no. I think question 1, I'll work through it as well, and then the future questions, I'll let you guys have a head start. Okay, so that's full answer for question 1, and I'll leave question 2 here, so you can have a head start with question 2. I'll start going through the answer for question 2 now. So note that question 2 has no stationary points. Once you're done with 2, move on to 3. So 3, I would recommend you guys to change those numbers to a fraction first. Will make your life a little bit easier.
How do you know there's no stationary point?
Because when you square a number, you can't get a negative number.
Oh.
So there's no solution to that. So there's no stationary point. So for question 3, make sure you factorize it first. It will make it a lot easier to calculate the values later. Did you guys get the derivative for question 3? When you derive it, you need to use the normal one, not the factorized one. The factorized one is only when you substitute values in, like this one here. Yeah, and then when you're finding, so this is finding stationary points. When you're finding stationary points, you need to substitute that you're finding x when the derivative equals to 0. Yeah? Any question?
Why do you not put the negative 1.5 and 2.5 in the first?
Yeah, I'm doing that here.
Oh.
Yeah, so I should show you guys the derivative first because there are a few techniques like the factorized one for the normal, and then you also have to factorize derivative in order to solve for, yeah. You can do either way as long as you find the y value. So remember there are 2 types of y values, start and end point, and the stationary points. You can do them in whichever order.
Would this be a calculator question?
I don't think so. Because you can do this division. You're supposed to be able to do, like, let's say 81 divided by 4. Just long division, right? 2, remainder 0, drop 1 will be 0, and then borrow a 0.2, remainder 2, and then borrow 0, 5. Or you can do long division. Long division will be like 8 subtract, get 0, drop 1, 0 times that would be 0, subtract, get 1, borrow, and then will be 8 subtract, get 2, borrow, and then times 5 subtract, get 0. Yeah, so that's a long division of 81 divided by 4. Or you can half it and half it again. Yeah, I've seen some tech-free questions where they give some symbol. This is considered a simple decimal number, right? Like you can't do something like 81 divided by 7. That one's too weird, right? It's not a finished. It's not. It's a recurring. It's a recurring decimal. But if it's like a non-recurring decimal, then they could give you that in the exam. Okay. All right. Okay, once you're done with that, move on to question 5. Okay, I'll start working through question 5. I will show the answer in terms of order. So I'll work on A first. But for you guys, you should try to do the other ones, B, C, D, E, right, and go to A last. But I'll just have A first for the sake of the recording. Mhm.
For all these questions that we did, do we have to show the nature for each one?
The nature for stationary points.
Yeah.
So for the first few questions, no, you don't need them, right? Because you don't really care whether it's concaving up or down. It's just the y value. You know it's a stationary point. You just gotta compare all the y values. However, for this one, question C, I would still check the nature for question C, because they said that find the coordinates of the local maximum, and we found out that there are two values. One is rejected, but you gotta make sure the other one is a local maximum. So I'll use the second derivative to check for the value. Okay. Or if you want, you can use the first derivative and then use the table, the gradient table. That might be a bit easier. But yeah, I just use the second derivative because this chapter is about the second derivative. Alright, so that's all of the explanation for question 5. Quite long, so if you need any help, so help you listening, just scroll back into the notes and you find them. Otherwise, I'll end the first half of the recording now.